Hello everyone, myself Kunal and I'm your mathematics tutor, and today is our fifth lecture on indefinite integrals. And जैसा कि हमने पिछले क्लास में बताया था, some standard form of algebraic integration, right? तो सबसे पहले आज उस पर हम प्रॉब्लम सॉल्व करेंगे, क्योंकि जस्ट वी रोड सम 8 to 9 बेसिक स्टैंडर्ड फॉर्म, और उसकी कल मैंने प्रूव कर दी थी। कल टेक्नोमेट्रिक सब्स्टिट्यूशन में हमने देखा था, जिसकी हेल्प से हमने वो सारे प्रूव करे थे। एंड टुडे वी लाइक सॉल्व फर्स्ट सम प्रॉब्लम on that, and then we move to the next technique, which is partial fraction. Okay, so first we deal with some problem. So our first problem is like integration of dx divided by root under 9 minus x square. So if you look this problem, what is it? It is of the form जो हमने कल पढ़ी थी, उसकी स्टैंडर्ड फॉर्म से ये मैच हो रही है। एंड द फॉर्म इज इंटीग्रल ऑफ dx root under a square minus x square, and we know that it integrates square minus x square, and when we compare this to this, so we get uh, like sine inverse of x by a, where a is 3. So this is our integration value. So now we move to the second problem, which is something like dx divided by 8 plus x square. So how can we reduce this complex integrand to our standard algebraic integrand? So it is of the form like dx, something we can write 2 root 2 square plus x square. So this integrand is of the form like dx by a square plus x square, and we know that its integral is nothing but 1 by a tan inverse of x by a. So 1 by a tan inverse of x by a, where a is, this is our a is 2 root 2, so we plus constant, so we get integrand as 1 by 2 root 2 tan inverse of, what is a here is 2 root 2 plus some k constant. I hope you'll understand this problem. We just try to reduce our integrand to basic integrand, basic standard integrand of algebraic function, which we will already read yesterday. So let's on move to the next problem. So let me add some page. Okay, this is our page 2. So our next problem is look like third problem, which is look like dx divided by 9 minus x plus 3 whole square. Okay, so here just x is replaced by x plus 3 if we compare it to the standard form. So we know that it is of the form root under a square minus x square, where x is just x plus 3. X is just replaced by x plus 3. So what is its integration? Its integration is sine inverse of x plus 3 by 3, because this is the square of, so this is our a. So sine inverse x plus 3 plus some constant k. I hope you'll all understand that. Let's move on to the next problem, which is the fourth one. Dx by, here written is x square plus x plus 1. So this is of the form like 1 by something quadratic written, right? This is a quadratic function, and we have to integrate this. So what is our approach? We have to convert this function, this integrand, to a basic standard algebraic integrand जो हमने कल पढ़ी थी. So we are like either we convert it into something like whole square, something y whole square plus a square, and we know its integration is 1 by a tan inverse y by a. So we can do that. Either we can convert it into some next form like a square x x square minus a square. So its integration is something like 1 by 2a ln 1, which we already read. So now move on to the this problem. So how to do that? So we use some basic quadratic equation concept to convert it into a perfect square. So what we do here, we know that something square, if we write x plus y square, so it's something related to x square plus 2xy plus y square, right? So try to generate here of this form. So what we do, we can write x square plus, we need to write, so we can write 2 into 1 by 2 into x, and we can write this one as, because this is our uh, y term. So here we have to write the y square term, and we can write this 1 as 3 by 4, because we know that 1 is equal to 1 by 4 plus 3 by 4. We can write it as. So this is our perfect square term, and this is some a term which we can write it into square form like dx by x plus 1 by 2 whole square plus root 3 by 2 whole square. We can write it as into this form. And we know that this is of the form like where our x is x plus 1 by 2 divided by a square. That is tan inverse of x by root 3 by 2 plus some constant k. I hope you'll all understand this. So let's move on to the fourth problem. Okay. So what is it? Our fourth problem is integration of dx. Our function now is 3x square plus x plus 1. So again, there is a quadratic equation in our denominator. So what we have to do, first we have to make the coefficient of x square as 1. This is the prior work we have to do. जैसे जैसे practice करोगे समझ में आ जाएगी कि next step क्या करनी है. So we have to just do, first make coefficient of x square as 1. So what I have to do, I have to take 3 common. So when we take 3 as common, so what I get, 1 by 3. Here will be like x square plus 1 by 3x, like 1 by 3x, and then plus, when we take 3 common, it will be like 1 by 3. And now try to make this quadratic function into a perfect square form. There will be some perfect square form, and there will be some constant, or either y square minus a square, anything you can create. So now let's move on to create this. So what we do, we know that a plus b whole square is a square plus 2ab plus b square. So we have to create it. Integration of dx divided by x square plus, we have to generate a 2 here. So what I have to do here, I have to do is like 1 by 6, 2 into 1 by 6, 2 into 1 by 6 into x. It's just this term. And then I have to do 1 by 3 minus 1 by 36. Right. I hope you'll all understand that what I do is 1 by 36 plus. Because this is our b term, so its square is 1 by 36. And but there is our 1 by 3, so we just add and subtract 1 by 36 term. So this whole term is the perfect square of dx. This whole term is the perfect square of x plus 1 by 6 whole square. And when we subtract this, we get as 11 by 36. We can write this term as actually plus root 11 by 6 whole square. So it's again of the form like a square plus x square. So we know that here a is this term. So our integration is 1 by a tan inverse x by a. So root 11 by 6 tan inverse x is x plus 1 by 6 divided by a. And the a term is root 11 by 6. I hope you'll all understand this. Okay, so let's move on to the next problem. And I think I missed something. Okay, so there is 1 by 3 too. When we solve that, it will be like 2 by root 11 and tan inverse 6x plus 1 by root 11. Because 1 by 6 got cancelled. So plus some constant. This is our integration. Let's move on to the next page. This is our fourth page. So our next example is, which is what next one? Yeah? Okay. So we deal four problem. Okay. So our next example is the fifth one, which is something look like integration of dx divided by, here written is 2x minus 3x square plus 4. So what I have to do first, I have to make, first I have to arrange this in a decreasing order term. So minus 3x square plus 2x plus 4. And what I have to do now, I have to just make the coefficient of x square as 1. So what I have to do, I have to just take the common minus 1 by 3. So here is like x square minus 2 by 3x. And when we take the common minus 3, so here will be like minus 4 by 3. I hope you all understand this. And then try to make this as into a form of a perfect square and uh, some constant term. So when we do that, it will be like minus 1 by 3. And we have to generate here like something. But here one thing is given, 2 is already generated here. So just we have to write it as dx x square minus 2ab. And so our a term, so our b term is 1 by 3. So what we have to do? We have to do just plus 1 by 9 and minus 1 by 9. Okay. So what we have to write, plus 1 by 9 and minus of 4 by 3 plus 1 by 9. What I do, I just subtract and add 1 by 9 because our b term is this. Right? So we have to generate its square too. So what I get, minus 4 by 3 plus 1 by 9. So when we write it into a perfect square, it something look like x minus 1 by 3 whole square, and minus, when we add this, what we get, 13 by 9. It's something look like root 13 by 3 whole square. Now this is of the form like x square 1 by x square minus a square, right? I hope you'll all understand this. So this problem here is of the form 1 by x square minus a square. So when we take minus inside, it's something look like 1 by 3 dx root 13 by 3 whole square minus x minus 1 by 3. So now it's converted into like a square minus x squared. Okay. And we know that the integration of a square minus x square is, uh, let me add the next page. So our integration will be like yesterday we read the formula, which is like 1 by 3, actually 1 by 2a. So our 2a value will be like root 13 by 3, 1 by a, log term आता था ln x, a plus x, so mod of ln, our a is root 13 by 3 plus x term will be like x minus 1 by 3 and by a minus x, so it will be like root 13 by 3 minus x minus 1 by 3. We have to take mod and plus of constant. So this is our integration. I hope you'll all understand this. Now let's move on to the last question. After that, we will move to the partial fraction part, like how to integrate by partial fraction. Okay. So our next question, something look like, next problem is something look like dx. It's our next problem. Integration of dx, something like x root under x square plus 1. Okay. So if you look here, like our integrand look like something written linear and linear function in denominator and a quadratic function within our root. So what we have to do, like we know that this is of the form like this function of the form like a square plus x square, right? Where a is 2, we can write this 4 as 2 square. So this function look like a square, root under of a square plus x square term, right? So yesterday we read the trigonometric substitution with the following cases, right? So here we cannot directly apply the standard algebraic form because यहाँ पे जैसे linear function आ गया ना, so हम convert directly नहीं कर सकते हैं. So what we have to do, we have to use the substitution method to integrate this function. I hope you'll all understand this. What I have to do, I have to just use the basic trigonometric substitution to solve this problem. And we know that uh, when the function is a form a square plus x square, so we try to substitute x as a tan theta. So try to substitute here. A is equal to 2 tan theta. Basically, our a value is 2. So what we do here, we do a substitution. Here. And what's our substitution is? Our substitution look like x is equal to a tan theta. Okay, and here our a is 2, so 2 tan theta, right? I hope you'll all understand this. And then try to convert to our new integrand. So our new integrand look like, so here dx is 2 sec square theta d theta. I hope you'll all understand this. So when we put there's a value of x and dx in our given integrand, so what we get? We get 2 sec square theta d theta as our dx and 2 tan theta and then 4 tan square theta plus 4. So when we integrate this, what we get? 2 sec square theta. When we manipulate or this, so what we get? 2 tan theta and 1 plus tan square theta will be like sec square theta, so 2 sec theta. So now here, when we simplify this, so sec gone, and when we simplify this, what we get? We get and this 2 get cancelled. So we get simple as sec theta by tan theta d theta. And when we simplify it into basic sine and cos form, so sec theta will be like 1 by cos theta. This will be sine theta by cos theta. So our cos theta get cancelled. So what we get? 1 by 2 cosec theta d theta, right? And we know the integration of, cosec theta will be like ln, what is it? Cosec theta minus cot theta. So try to write that ln mod of cosec theta minus cot theta plus some constant. Now our major work is to convert these function cosec theta and cot theta into given function into the term of x. So what we do here, we actually substitute x is equal to 2 tan theta, right? What we substitute here, x is equal to 2 tan theta. So x by 2 is tan theta. So we have to substitute it to cot theta first. So our cot theta will be like 2 by x, 1 I get, and now I have to convert it into cosec theta. So cosec theta will be like cosec square theta is equal to 1 plus cot square theta. It's the basic formula. I hope you'll all know this. So when we substitute here, so what will be 1 by 4 by x square? So it will look like x square by 4 by x, okay, and root over, right? So x square here. So when we solve here, what we get? Ln cosec theta as root under 4 plus x square minus 2 by x plus some constant k. So this is our integration of this complex function. I hope you'll all understand this problem. So now let's move on to the our new technique. अभी तक हमने क्या क्या पढ़ लिया? Try to recap me. हमने बेसिक प्रॉपर्टी देख लिए और बेसिक फॉर्मूला. देन वी मूव ऑन टू द टेक्निक ऑफ इंटीग्रेशन जिसमें हमने सब्स्टिट्यूशन देख लिया, बाय पार्ट्स देख लिया. उसके बाद सम बेसिक फॉर्मूला, अलजेब्राइक स्टैंडर्ड फॉर्मूला देखा. देन वी सम इम्पॉर्टेंट ट्रिग्नोमेट्रिक सब्स्टिट्यूशन एंड सम बेसिक प्रॉब्लम भी हमने करे. So today we move to the our third part, which is third part of technique of integration, which is partial fraction. So we start integration using partial fraction. So before starting this, we have to first try to know that what is proper fraction and improper fraction. Proper fraction, we have some basic knowledge of proper fraction and improper fraction. So we know that if the degree of numerator is greater than equal to degree of denominator, then it will be improper fraction. So what I'm saying is if degree of numerator, and R will be like numerator, shorthand notation, will be greater than equal to degree of denominator. Degree of denominator. So we can tell it as improper fraction. And what is proper fraction? So if degree of numerator is less than equal to degree of denominator, less than, not equal to, less than degree of denominator. Okay. So if px by qx is our fraction, this is our fraction. So what we do here, we just only deal with the proper fraction because in which the degree in denominator is more while solving the partial fraction. Because if like both cases देखते हैं, अगर improper fraction given है, like something px by qx is our given function and we have to integrate this function, and this is improper fraction, like px by qx is improper fraction. That means if the degree of numerator is greater than equal to degree of denominator. So what is the approach to solve this problem? We just divide numerator by denominator. Like if there is a term like x5 plus 4 divided by x dx. So this is our improper fraction because degree in the denominator is 1 and the degree in denominator is 5. Degree of x is 5. So what we have to do? This is an improper fraction because degree of numerator is greater than degree of denominator. So what we have to do? We have to just divide numerator by denominator. So when we divide, it converted into x to the power 4 plus 4 by x dx. And we know that this is of the form like x to the power n integration. So its integration will be like x to the power n plus 1 by n plus 1. So it will be like x to the power 5 by 5. And we know that integration of 1 by x is ln mod x. So ln mod x plus constant k. So this is for improper fraction. But what if the fraction given is proper fraction? Okay. What if the fraction is an algebraic fraction is proper fraction? Something like that. If I will give you example, so it will be like x plus 4 something divided by x minus 2. We can take, okay, x minus 2 into x minus 5 dx. So this is our improper fraction because degree in numerator is when we multiply this. So let me multiply here x plus 4. So when we multiply this, x square minus 7x plus 10, right? Dx, right? So here the degree of x in denominator is 2 and the degree of x in numerator is 1. So here this is proper fraction. So like how to approach this kind of fraction. So there is a way called as partial fraction. So what we do is we can write this fraction. This is our px by qx form. So we can write this function as some coefficient a by x minus 2 plus b by x minus 5, where a is some constant and b is some another constant. So what we have to do, we have to just find a and b, and we know that this is of the form like 1 by x. So its integration is ln mod x. So we can easily find the solution. So what we do here, we just try to convert it into proper fraction is given, and we just try to convert it into uh, some partial fraction, like different fraction with some constant in numerator. So what is the next step? So next step will be like we just compare it to the LH. We just compare here LHS and RHS. When we compare LHS and RHS, so what we get here, look at this, like x plus 4 by x minus 2 into x minus 5 is equal to x minus 2 into x minus 5, a into x minus 5 plus b into x minus 2. I hope you'll all understand this, what I'm saying. So now x plus 4 is equal to, this will get comparison, this will be same, so we can also neglect this. So what is our a into x minus 5 plus b into x minus 2. So when we do that, what we get a plus, when we simply simplify it, so what we get a plus b into x minus 5a minus 2b. And here we know that the coefficient of x in LHS is 1. So coefficient of x in RHS must be 1. So what we get here, a plus b equal to 1. So this is our first equation. And we know that this is our constant term, right? So the constant term will be something look like minus 5a minus 2b is equal to 4. When we solve this both equation 1 and 2 by using normal linear equation method. So what we get here is we get a is equal to minus 2 and b is equal to 3. So what is our fraction given is px by qx is given like x plus 4 divided x minus 2 into x minus 5. So we can also write this fraction as minus 2 by x minus 2 plus 3 by x minus 5. And when we have to integrate this fraction, this proper fraction, so when we integrate this fraction, this is of the simply form like 1 by x form. So its integration will be ln x. So we can write it as minus 2 ln mod x minus 2 plus 3 ln mod x minus 5 plus some constant. I hope you'll understand this partial method form. So we try to practice one or two more questions, so it will be automatically understandable to you. So let's move on to the next question. Okay. But remember that whenever we apply the partial fraction, the fraction should be proper. That means degree of denominator is more than degree of numerator. So our next problem is integration of 3x minus 2 divided by x plus 1 whole square into x plus 3. So look at here. What I'm saying is, here the degree in denominator is 2 and 1, 3, and the degree in numerator is 1. So here the degree of denominator is greater than degree of numerator. So this function will be proper fraction. So we can apply here the partial uh, fraction method to integrate this integrand. So what I have to write first, we can write this function x plus 1 x whole square x plus 3 as uh, in the product form of this function. So what we write, a by x plus 1 plus b by x plus 1 whole square plus c by x plus 3. And we have to just compare the LHS and RHS and try to find the value of a, b, and c function. So how can we approach this? We first write this function as 3x minus 2 uh, divided by x plus 1 whole square into x plus 3. And we simplify the right hand side. So what we get? We will like x plus 1 whole square. When we take LCM, x plus 3. Here we get a into x plus 1 into x plus 3. We just simplifying the RHS and try to compare the LHS and RHS to get B, so that we convert this complex part to a simple favorable integrand. B into x plus 3 and plus c into x plus 1 whole square. We can remove the denominator part because it will be same in the both LHS and RHS. So now compare. So what we get here, 3x minus 2 is equal to a into x plus 1 into x plus 3 plus b into x plus 3 plus c into x plus 1 ka whole square. So we know that in LHS coefficient of x square is 0. So it must be in right hand side, coefficient of x square is 0. So we get x square from here and here. So what we get actually, we get a plus c equal to 0. This will be compared by coefficient of x square, and then we get 3 on solving 4a plus b plus 2c. This is the coefficient of x, and then we get minus 2 as 3a. Here will be 3a, here will be 3b, and plus constant. We just do the coefficient of x square, coefficient of x, and coefficient and the constant term. I hope you'll all understand this. अगर नहीं समझ में आया मैं फिर से एक बार बताता हूँ. What we do here, like ये हमारे पास एक proper fraction दिया हुआ था, 3x plus 2x plus 1 whole square x plus 3. So this is a proper fraction because denominator की degree ज़्यादा है numerator से. So we can apply partial fraction here. So what I do, we can write this proper fraction into some expression which consists of denominator term, right? So, and then we have to compare the LHS and RHS to try to find this value of A, B, and C. And we just solve this problem, and we get the 3 equation here. The first equation is A plus C is equal to 0. This equation we get by comparing the coefficient of x square is 0 in both LHS and RHS, and this equation we get by comparing the coefficient of x, and this equation we get by coefficient of constant. Okay, so when we solve this all 3 equation, so what we get, a is equal to 11 by 4. Try to solve this equation. Like first do a is equal to minus a here. From first equation we get, and then subtract this first, second and third equation. So when we subtract this, what we get? A plus A, let me erase this. Okay, so here we get A minus 2B plus C is equal to 5, right? A minus, and we know that these both term will be 0 because A is equal to minus A. So this get cancelled. So B is equal to minus 5 by 2. And when we solve this, we get A is equal to 11 by 4, B is equal to minus 5 by 2, and C is equal to minus 11 by 4. So hence we write this whole problem into the form of, so our integration is look like something uh, A, we can do directly, right? Like A, ln, because if we go through here, uh, what we get from here, like x plus 1, x plus 3 got cancelled. So here we get A by x plus 1 term, right? So its integration will be ln A ln mod of x plus 1, right? And then uh, plus B term, and it will be like minus 1 by x plus 1. Just integrate the form, and then we get C ln mod x plus 3. And then try to substitute here the value of A, B, and C. So what we get? 11 by 4 ln mod x plus 1. Sorry, minus 5 by 2 is here than minus. That will be like minus 5 by 2 ln, sorry, ln not. It will be minus 1 by x. So we get plus, and it will be like x plus 1. And then our C value is minus 11 by 4. So minus 11 by 4 ln mod of x plus 3 and plus some constant. So this is our basic partial fraction method to solve the integration of proper fraction. I hope you'll all understand this, how to solve. We have to just, uh, first we have to write the denominator term into the, as an expression in the right hand side. And then we have to compare the LHS and RHS to find some constant. And when we do so, our integral is converted into separable integral, as we see here. So then we just simplify it and find the value of constant, and our integral will be ready. Okay, so we saw one more problem, and then we move on to the some algebraic integration special cases. So let's solve one more problem here. Okay, so our problem look like, our next problem is, let me write here. Our problem look like, uh, here is 2x minus 1. Our next problem, integration of 2x minus 1 divided by x minus 1 into x plus 2 into x minus 3 dx. Let me hold 1 second. Okay, so this is our integrand given, and we know that this is a proper fraction because here the degree of numerator is 1 and the degree of denominator is 1, 2, and 3. So this is proper fraction. So we can apply here partial fraction. So just try to solve this. So what we have to do, we have to write this function 2x minus 1 by x minus 1, x plus 2 into x minus 3 as integration of a by x minus 1 plus b by x plus 2 plus c by x minus 3. Now there is a shortcut method which is also a small trick to directly find out the value of a, b, and c. So what we have to do, just put the value of x in the LHS. So whatever we get is the value of a. Let me write here. So the value of a is just put the value, whatever written in denominator. So x is equal to 1, put in LHS, except the x minus 1 term. So what we get here, 2 into 1 minus 1 divided 1 plus 2 and 1 minus 3. It will be like 1 by minus x. So this is our a value. Similarly, the value of b is, this is a small trick. So try to apply for easy solving. So the value of b is, put x is equal to, like here the x is equal to 2, right? X is equal to minus 2. So put in LHS, but accept the x plus 2 term. बेसिकली यहाँ पे जो भी है इसको जीरो से इक्वेट करते हैं, तो विल लाइक माइनस टू, बट इसमें नहीं रखनी है, इसके अलावा जो भी टर्म है उसमें सब में वैल्यू को रख देते हैं. सो व्हेन वी पुट हियर व्हाट वी गेट, 2 into minus 2 minus 1 divided by minus 2 minus 1, x minus 1 1, and then minus 2 minus 3. So what we get here, minus 5 divided minus 5 into minus 3. So we get minus 1 by 3. We get the value of b as minus 1 by 3. Now let's move on to the c, value of c. It will be like value of c is equal to, put x is equal to 3 in LHS, because here the denominator term consists of x minus 3. When we put, we get the value of c as 1 by 2. So try to replicate that. So our integration look like a ln mod of x minus 1 plus b. This is some short trick, like प्रैक्टिस जितना ज्यादा करोगे ना वो चीजें जल्दी जल्दी होने लगेंगी. CLN mod of x plus x minus 3, and we get the value of a, which is minus 1 by 6, ln mod x minus 1 plus the value of b we get is minus 1 by 3. So let me erase that. It will be like minus 1 by 3 ln x plus 2, and the value of c we get is 1 by 2. So 1 by 2 ln mod of x minus 3 plus some constant. So this is our basic solution. And now we move on to the some special cases in algebraic integration. We start it today and deal with it definitely in tomorrow, because we just start this and watch some cases, some special cases, give this kind of problem given exam. So how to approach the problem. So this is our algebraic. Let me read it first. So our type 1. If our given integral of the form linear by linear, L represent the linear, L represent linear, Q represent quadratic. There is a shorthand notation which I use in further lectures. C represent cubic. So if a given integrand of the form linear by linear, linear 1 by root over linear, and linear 1 into root over linear 2. So how to integrate this kind of problem? So what we do is we actually write the linear form in numerator is expressed by linear form in denominator. So what we have to do is we have to just write linear 1 is equal to, this is important. We have to write linear 1, express linear 1 in term of linear 2, K2, and equate and find K1, equate and find whatever K1 and K2. Equate and find K1 and K2. So this will be quite helpful. So if there is a algebraic integration of these three form like linear by linear, linear by root over linear, or linear into root linear. So try to express the linear form which is in denominator into numerator. So Now let's move on to the next type. This is type 2. Let me write. Okay. So our type 2 will something look like if linear by quadratic, linear by root under quadratic, and don't try to worry because हमें नेक्स्ट क्लास में इस पे जितने भी हमने ये कॉन्सेप्ट पढ़ रहे हैं ना उस पे प्रॉब्लम सॉल्व भी करी जाएगी. सो डोंट ट्राई टू वरी मच. प्रॉब्लम सॉल्व करेंगे तो उससे चीजें और भी अच्छे समझ में आ जाएंगे. Our next part is linear by quadratic, linear by root quadratic, and linear root quadratic. So what we have to do is we have to write the linear function into some constant k1 and differentiate the quadratic and plus k2. So what I done here, I just express the differentiation of quadratic into linear form. Equate and find k1, k2. So this is our next basic form. I hope you'll all understand this. Let's move on to the third part. Tomorrow we discuss problem on each type. So first read some type and how to uh, how to approach this problem. We are just looking into it. So type 3 will be like if quadratic by quadratic or quadratic by root over quadratic. So how to approach this? So write actually the quadratic which given in numerator as k1 q2 plus k2 q2 differentiation of q2 plus k3. This is our basic form. Equate and find k1, k2 and k3. I hope you'll all understand this. We discuss some problem in next class, so don't try to worry more. Let's move to the type 4. So our type 4 is 1 by linear root quadratic. So what we have to do is we have to just put, let me erase it. Just put support linear term is equal to 1 by 2. This is a variable. Support substitute this value like linear by 1 by t and then reduce the expression to 1 by root quadratic. And we know the how to integrate the 1 by root quadratic term. We first try to make, आज हमने इस पे problem भी solve करी है. We first try to make this square a perfect square and plus some constant square, and then try to use the standard algebraic integration. Perfect, some perfect square plus a square. I hope you'll all read that. So in tomorrow class, we discuss some problem on these four basic type, and read some more special type, standard type, special type of algebraic integration. I hope you'll all understand today's lecture. So thank you everyone.